Okay, we have a second order differential equation with equals 0 on the right hand side, which makes our life simpler. So we start off by solving the auxiliary equation. So we've got 4m squared plus 4m plus 37 equals 0. So on the calculator that generates m is minus a half plus or minus 3i. So now we know that h, the general solution of h, is e to the minus a half t times a cos 3t plus b sine 3t. Right, so we know when t is 0, the end of the diving board is 20 centimeters below E and moving up with a speed of 55. So let's find dh by dt, because that will give us the speed. That's minus a half plus product rule, minus 3a sine 3t, layout, sorry, plus 3b cos 3t. Always start right to left. I don't know why I've started it in. Okay, and t is 0. H is minus 20. And also that gives us minus 20 equals, that's 1 cos 0, so just a. So that's a found, that's easy enough. And when t is 0, dh by dt is 55. So that gives us 55 equals minus a half a plus 3b, because the signs will be 0. We already know a, so 55 equals 10 plus 3b. That tells us that b equals 15. Okay, so I've got h equals e to the minus a half t times 15 sine 3t Okay. Find, according to the model, the maximum vertical displacement. So I want to know when dh by dt is 0. I've already worked out dh by dt, so that's, I'll take a factor of e to minus a half t out. And then I've got minus a half 15 sine 3t plus 60 3t 45 cos 3t. Okay, now we want that to equal 0, and we know that the exponential can't be 0, so that implies this is 0. So we've got 15 sine 3t doubling everything. Take away 20 cos 3t. Okay, and then that equals 120 sine 3t plus 90 cos 3t. So I've made this equal to 0, move that across, well, whichever way you want to do it, move that across the other side, so it doesn't equal, so it's positive, and then I've doubled everything. So I've probably done 2 steps in one there. So we get minus 105 sine 3t equals 110 cos 3t. So tan 3t is minus 110 over 105, and that implies t so the maximum displacement, we found the value of t. We're going to plug that back in again. Okay, so we've got t, and then we need to find h, is what the question asked for. H is up here. So when t is 0.778, h, we put it into there, equals 16.7 centimeters. There's a comment on the suitability of the model for large values of t. Okay, so as t gets larger, so as t gets larger, h becomes very small. It becomes small because this is e to the minus a large number, so you're dividing by a very large number, which I think is realistic, as the board will eventually stop. Okay.